Last time we learned that converting from truth table to Boolean equation is important in several aspects. And this time we're going to learn some techniques in order to perform that task. And that technique's based on the two important terminologies that we need to know, which are the mean terms and the max terms. So the mean terms is denoted with the name m lowercase, and it is the products or the dot products or the and operators of all involving inputs. Let's say if you have the equation of y equal to a and b and c, let's say with three inputs, then that mean term have to have some involves of all those input A and B, C. A have to appears there, whether A or its negative version, or B or its negative version, or C or its negative version. So next one is, again, that whether it's A or its negative version appears there depends on that expression or that Boolean equation for the mean term, okay, is evaluated to true given the inputs. It's going to be evaluated to the true given the input. We'll have example later. Very much similar, we have the dual form, which is the max term. It's going to be denoted as capitalized M, and instead of products, it's the sum, or it is OR operators involving all the inputs. Again, if y equal to a, b, c something, and it's a have to appear in this expression, b have to appear in this expression, and c have to appear in this expression. All of them have to appear there. But whether a appear in its form or its negative form and so on and so forth for b, c, depending on how they add up and they produce false result. Okay, and that one is called the max terms. Now, if you have a truth table of n lines, then you will have n corresponding mean terms. Or let's say if you have a truth table n inputs, then you want to have 2 power n combinations of the inputs, mean 2 power n rows. Then you will have 2 power n mean terms, and you'll have 2 power n max term ranging from 0 to 2 power n minus 1. And this one is, what it means is for every single combination of the input, there is one corresponding mean term or max terms, okay, which is products of all the input evaluated to be true, or sum of all the inputs evaluated to be false. Now let's just go with one example. I think it will be a lot easier to understand, which is this one. Let's just continue with our example about a picnic, and we have the truth table over here. So if we would like to find the mean terms, again, it has to be somehow products of, for this line, it have to be somehow the products of A and R. And whether it is A or its negative version, it depends on this mean term gonna produce true or false. We want it to produce true. So it's gonna be not A and not R, because not A and not R produce 1. We don't have such thing like A and not R, let's say, because it's gonna produce false. Or if we don't have such thing like a not R and A, because it's gonna produce false. A and R is not a mean term for this because it's produce false. So not A and not R is the mean term. Again, why? Because it involves both of the input, which is A and R, and it is the products, okay, and it is evaluated to be 1. That one is the thing that we have learned. Similarly, for this line, the mean term will be not A and R. So you'll see not A and R here because it's involve both A and R, and A is negated because this one is going to help us to produce true. Similarly, next line will be A not R. Similarly, next line will be A and R equal to 1, because this is 1 and 1 equal to 1. So here are the mean terms. Okay? Again, very importantly, it involves all the inputs and is evaluated to be 1. Okay? Now the name of the mean term is denoted by a lowercase, and we have two inputs. So its combination is gonna be 4. So we name them from 0 to 3. So M0, M1, M2, M3. Okay. Very much similar. We'll have our max term again. It's have to involve all the inputs. Okay. And it is evaluated to be false. Okay. And they are using 4. So if A or R is gonna be false, so this one is A or R. Because let's say A and not R will be 0 or 0 or 1. It's gonna be 1. So this one is not. So this one have to be A R. The next one will be A not R, okay, because it's evaluated to be 0. The next one will be not A R. The next one will be not R. So one of the tricks for us to memorize is if you want the mean terms, if it is 0, you have its negative version. Okay. If it is 0, you have negative version. If it is 1, you have its own version. Okay. But if you use max term, if it is 0, just skip it. Okay. If it is 1, you negate it. If it is 1, you negate it here. Okay. We're going to name this one using capitalized M. So you have M0, M1, M2, M3, and so on and so forth. Okay. So that one is the mean terms and the max terms. And we'll see what the mean terms and the max terms for. Again, they help us to convert from truth table to Boolean algebra. How? So there are several ways of doing that. We'll do the first way is the sum of products form. What does it do is, it's a way to convert truth table from Boolean equation using the products, or that products is the mean terms. Okay, so you just sum all the mean terms where the output equal to 1. It's going to be there. So here is the details. So we start with the truth table. If you have the truth table, then you find the mean terms, okay, like what I've done so far. Then you just simply sum all the mean terms where the output column equal to 1. So if you see the output column equal to 1, you're gonna just sum them. Okay, so the mean terms is actually the products of the inputs, the combination of the inputs. So you sum all the mean terms mean you sum all the products. Okay, so it's a sum of the products. They don't want to say sum of mean terms, because if you sum of mean terms, you may sum all of them. But we'll just say sum of products, which is only sum the mean terms where the output equal to 1. So from there, we'll get our Boolean equation. So let's just give an example. We'll see from here that we have done earlier, and we're using the sum of products form. We have done the problem definition of the picnic problem there. When we build the truth table, we find the mean term, we find the max terms already. Then right now we want to convert this truth table into Boolean algebra. We'll find where the output column equal to 1, which is this one. Okay? This one is a line where the output column equal to 1. Okay? All the other lines, the output columns are equal to 0. Again, output column, not the mean term, okay? Because the mean term always equal to 1. Okay? But the output column E equal to 1 over here, and I will sum that mean term, and that mean term is not A and not R. So I'll have E equal to not A and not R. And this one is the Boolean equation that's gonna produce the same output as this truth table. And that one is, how do we use sum of products rules in order to build the Boolean algebra equation from the truth table using the mean terms. Okay? So why? Again, because it's simpler comparing to the whole truth table. Next, it helps to wire the circuit, as we have seen earlier, and like this. Okay? And the next one is helps in the simplification process, because we have learned that this can be simplified. How? We'll see later. We'll study Boolean algebra later. Okay. Very much similar to sum of products, we do have its dual form called products of sum. Again, it is another way to convert truth table to Boolean equation. So you have the truth table again, okay? Then you're going to find the max terms. I've learned that. Then you're going to just no, this one. We're going to just products. Okay, all the max terms when the output equal to 0. Okay, you just product, or you just do the n, the max term where the output equal to 0. Okay, so this one is it's dual form. So we'll be able to generate the Boolean equations from there. Now this one is the same example before. We'll see we have the specification, we build the truth table, we find the min terms and the max term. Then right now we'll see that the max terms over here. The rules is we're going to find all the max terms where the output equal to 0. So here is the output. It's equal to 0 are all this. And we need to product them. So here are all the outputs that equal to 0. This output equal to 0. And their max terms are M1, M2, M3. Or these are the max terms. And we need to product them. Okay, we need to product them. So for this, it's going to produce A and not R. So this is the first max term. Dot products with not A and R, which is not A and R, and dot with not A, not R, which is dot with not A. And on top of this, we're going to be able to produce the circuit like this. Okay, we are able to produce the circuit like this. Okay. Now, why? Again, the same concept that we learned before is simpler. This one somehow is still simpler than the truth table. It have to wire the circuits and also have to do the simplifications. And we already seen that actually when we use the product of sums versus sum of products deserve the same problem. So the sum of products earlier produced better result comparing to product of sum. So what does it mean? When do we use which one? There is no clear rules, but normally when you have less number of true output, it's better to use sum of products. And when you have less number of false output, it's better to use product of sums. That one is their hints. Okay. So this one is the hint from there. So from here you can have an exercise as well, which is sum or product and product of sum. So I have provided some random business requirements on which I have built the truth table with 3 input A, B, and C, and here is the output. You need to find the mean term, you need to find the mean term names, you need to find the max term and max term names. And after that, you're going to produce the Boolean equations for each one of them and build the corresponding circuit.